I'm going to do a quick analysis of a photo with Logger Pro and do a tutorial over that. So first things first, you are going to need to have a photo saved to your computer. So what you guys have is your Trello board. So what you're going to want to do is go to the Trello board, go to this project, and go down to today's activity, which is the same one as yesterday, and you have all these attachments. So what I'm asking you guys to do is choose one of the class pictures. And you and your group are going to analyze that one. And it should be different than, than what other people in the class are doing, to kind of switch it up. So once you do that, you're going to download that picture. And you should know where it's saved on your computer. Open up Logger Pro, and you're going to go to Insert, and you're going to choose Picture, and you want to pick Picture with Photo Analysis, and that will give you the tools you need. Once you do that, it opens up a little Finder box, and you're going to locate your picture. I am going to do this version, which is a photograph from the physics lab at MIT. So I open that, and you want to go ahead and make this picture as big as possible. The larger your image is, the more accurate your results will be, simply because of it's minimizing the error. If you're trying to click on parts of the ball, the bigger the ball is, the easier it is to hit where you're actually shooting for. Okay, so we have our picture in the Logger Pro. So the first thing we need to do is set a origin. You can really pick wherever you want. You could pick down here. This will be the positive y-axis. This will be the positive x-axis if you want to. You could choose up here where the ball is located, which is perfectly logical. You could do down here. It's really entirely up to you. It does not matter. The only thing I would say is you don't want your axes to get in the way of your field of vision of the ball. So I would move it off to the side a little bit. Okay. Once you do that, you need to set some sort of scale. Logger Pro has no idea what this object is. So if I knew this gentleman's height, I could do his height. In your photos, you have a meter stick taped to the ladder, so I would do that. For this, I know that each of these marks is 1/4 of a meter, or 0.25 meters, or 25 centimeters. So I'm going to click on the bottom, and I'm going to hold and I'm going to drag this green line, and I'm going to go all the way up, because I know that that distance is 2 meters. When I let go, it asks me what that distance is. I'm going to type in a 2. Meters are the correct unit, so I don't have to change that, and just hit OK. All right. So I've set an origin, and I've set a scale, and now I'm ready to plot my points. So before you do anything, make sure you look carefully. So it looks like this is where the ball starts. There's my first image, second image, third, fourth, etc. Down here, it's going to land in this, so I can't see any images in there. So this is going to be my last image right here. So I go to my Add Points. That's my Add Point tool. Go to my first image, and you always want to choose a spot that you're going to be able to click on consistently. So I would choose like the bottom face of the ball or the top face of the ball. You could do the middle of the ball, but then you're having to estimate where the middle is, so that's why I always do an edge. So I'm going to click on the first image, and it puts a little dot, and then I'm going to go to the next image, try to find the bottom edge, little dot, try to find the bottom edge of the next one, etc. And this is why you want your photo zoomed in as much as possible, because the larger your photo, the easier it is to make sure you're hitting the actual edge of the ball. Alright, and there we go. So I've plotted my points on my image. Now what you want to do is make sure that you click off of that Add Point tool so you don't add an extra point someplace. Now if you wanted to, you could maybe have 2 objects in your video. You could add an additional set of points for an additional object if you wanted to by using this tool right here. But we're not doing that for this. Okay. So now we're pretty much done with that. Let's go ahead and if you do Command R, it will rearrange your page for you. And now what we're working with is our data table. So for this experiment, our ball is moving in the y direction. So if I look at the data that we have x values and y values. X values are how far away it is from the origin in the x direction. So it's the x value of that position. We don't really need that because our ball is moving straight up and down. And if you look at these numbers, they're pretty stinking close to each other. I've got 4.7 centimeters, 4.5 centimeters, 4.7. So these are off by millimeters from each other. And that's just from how I clicked my points. So I'm just going to delete those x values. I don't need them at all. Delete that column. Okay. So now I have my y values. And what I'm going to want to do is set up all my columns. So what you're going to need to find is displacement, velocity, and acceleration. So first, let's go do displacement. So go to Data, and you're going to go to New Calculated Column. We're going to have Logger Pro calculate this for us. So we want to call this displacement. And the short name for that is going to be delta y. So you can either do Alt-J, or you can go to Greek uppercases, choose delta and y, and that's delta y for the y dimension, and the units will be meters. For your equation, remember that delta y means change in y position. So what I wanted to do is take whatever my current position is and subtract the starting value, because that's how you find change in something. Go to Variables and choose y, and that's going to take whatever my y value is, and I want to subtract the starting value. Well, look at what your starting value is. Mine was negative 0.00265, so I'm going to type that. Yours will probably be different because your origin is in a different place. And then I hit done. And notice that what it did is it's taking whatever my y value is and subtracting 0.00265. So if I start there, it's 0. The next one, it's taking that and subtracting that. This one, it's taking that and subtracting that starting value. And I'm getting now my displacement. So if I wanted to, I could draw my displacement vectors, and they would have magnitudes of this for each moment, each image. So now I want to find velocity, but you notice that before I can do that, I need time. So I'm going to go to New Manual Column, and I'm going to type in my times. So I'm going to call this time. Short name is T, and units are seconds. I'm going to have it automatically generate my value, so I'm going to check that box. Our starting time logically would be 0. The ending time is going to be about 1 second, because that's what the camera was set to take a photo for. And now the increment. So this depends on your strobe light. So in class, your strobe light was going at 0.063 flashes per second. Or I'm sorry, seconds per flash. So you would put 0.063. This one, their strobe light was set to flash every 0.067 seconds. So I'm going to use that. And I hit done, and you can see that it generated my values, and all it did was add 0.067 each time. I could have done that manually with a calculator, but I didn't feel like it. It doesn't matter that you have extra of these. It's not a problem at all. Okay, so now I have displacement and I have time, so I can find velocity. Go to Data, New Calculated Column, Velocity, V in meters per second. And remember, velocity is delta displacement. So I'm going to do delta for my function, and then displacement divided by delta time. And then I'm going to hit done, and it gives me my velocity values. And then I also want to do acceleration, so I'm going to go up here again to calculated. Acceleration, A, meters per second. And you could put meters per second, that would be okay. Usually we transition to meters per second squared as our unit, just because it's easier to write and type. And now, this is also a rate, but instead of describing delta position or displacement, it's delta velocity. So I'm going to go to delta, choose my velocities, and then I'm dividing by delta time, and done. Okay, so what this just did is this velocity column, it took my change in position, so it subtracted this one from this one, and divided by the change in time. And it did that for each of these. It found the difference between these two, and divided them together. Difference between these two and these two, divided them together. Acceleration describes the change in velocity over time. So it found the difference between these two and divided by the difference between my times, and then so on and so on. So that's what those are actually giving you. Now, if you look at this was done at MIT, which is in Boston, and that's on Earth. The acceleration due to gravity on Earth should be around 9.8, and if you find the average of those, it should be. So let's see what our average is. So I'm going to actually look at the graph, which we haven't done in class yet, but we will. And I'm going to choose time. So I'm going to look at my velocity versus time, and the easiest way to find my acceleration is to find the slope of this, and it's about 8.847 meters per second. So I would expect it to be closer to about 9.8 or 10, but that's definitely within the margin of error of our putting dots on there. Now, of course, some of you guys are in pre-cal. You just did a curve fit in pre-cal. You could also do a curve fit of your displacement versus time. That's a quadratic if you try that fit, that a value for that first constant in your quadratic equation, that is half of your acceleration. So if you double that, that'll give your acceleration too. So we get, again, about 8.8, 8.9 for our acceleration, which, you know, I think it's safe to say that this is done on Earth, and that's a pretty reasonable value of acceleration in a simple experiment. All right, good job. Thank you very much.